Welcome to the Cloud Data Integration, Hierarchy Processing course. Hello, I'm Laura, and I'll be your guide through this training. Up in the right-hand corner, you'll notice a resources area. These resources will supplement and support this course. At the end of the training, there is a quiz. This quiz is designed to provide direct feedback on your knowledge of the content presented. You are always welcome to go back and review any of the information presented in this course. At the end of the course, you will be presented with a survey. Your feedback is critical to the success and further improvement of our courses. Please take a moment to complete this very important step. Now, let's move on to the objectives for this course. The objectives of this course are: understand hierarchy files in XML and JSON. Use the hierarchy parser to process a hierarchical file. Use the hierarchy builder to create a hierarchical file. Use the hierarchy processor and advanced mappings to process and create hierarchical files. Welcome to the Processing Hierarchies module. The two most common formats for hierarchy files are XML and JSON. Other formats, such as Avro, Parquet, and ORC, are used less often. An XML file like this one shows each field with a start and end tag. These tabs identify the field. Fields can be grouped, like the first and last name in the employee structure, and you can have an array of employees by just repeating the employee structure. This is a simple XML file. For more complex files, you may have a structured definition in an XSD file. Processing XML using the hierarchy parser requires an XSD file to be used. Now, this is the JSON example of the same data. You see the first and last names grouped by brackets to create the employee structure, and square brackets are used to create an array of employees. All fields have a name tag to identify them. This course focuses on processing and creating JSON files. Processing the other file types works similar, but there are slight variations in the configuration. CDI supports hierarchy processing in standard and advanced mappings. In the standard mappings, you have the hierarchy parser and hierarchy builder transformations to read and write XML and JSON. In the advanced mappings, you have the hierarchy processor for both reading and writing hierarchical formats. Supported formats are JSON, Avro, Parquet, and ORC. The hierarchy processor has added functionality, like field-level transformations, grouping and aggregating results. Whether to use the builder or parser in standard mode, or the processor in an advanced mapping, depends on the size and complexity of the file to create or parse, performance requirement, and the licensed runtime environments. Welcome to the Hierarchy Parser and Builder module. To use a hierarchy parser or builder, you need a schema definition. The schema definition imports an XML schema definition file, XSD, or a sample JSON file. Do not use a JSON schema file. The hierarchical schema definition is a separate object in the CDI repository. You can create it as a separate object before you create the mapping, or create it while configuring the hierarchy parser or builder. The hierarchical schema is used in the transformation to get the structure and field definitions. In the field mapping, you can address the individual elements and fields in the hierarchy. To create the hierarchical schema, click on New, Components. Create the schema by giving it a name, location, and the file to use. In the Upload step, you can validate the file. The hierarchy parser has two input methods, file and buffer. For file, you will specify the file name to process as data in another input file. File is the preferred method. You will use this in the exercise. Using buffer has limitations. It needs a fixed width file format, and the maximum file size is 32K. You then specify the schema to use, and you are ready to configure the parsing. The first step is to map the input to the hierarchical schema in the input field selection. The hierarchy parser reads the structure file and shows the fields in the Field Mapping tab. Expand the structure and select the fields you want to use. The hierarchy parser creates one or more output groups, depending on your selected fields. These output groups can then be mapped to downstream transformations in the mapping. The hierarchy builder works similarly, but there are some significant differences when creating a JSON file. To reduce the complexity, Create a hierarchical schema object using only one root and its children from the JSON file. This will ensure the output created is as clean as possible for further processing. Using a complete file works well with XML, but for JSON, this is the preferred method. You can drag multiple upstream sources to the hierarchy builder. They will be shown as different input groups in the file mapping. The hierarchy structure is used to create the output structure in the hierarchy builder. If you have multiple input groups, define the primary and foreign key relationships in the field mapping to link them as desired. Then drag and drop the input fields the output structure. Time for some exercises. In the following two labs, you will use the hierarchy parser to parse a JSON file and a hierarchy builder to create one. Click on the buttons to start the exercise.
The file bakery.json consists of items, representing three types of donut. Each item has an array of batters and toppings, showing the available variations. The items have a name, an ID, a type, and a PPU. The batters and toppings have an ID and a name. In this exercise, you will use the hierarchy parser to split the data in this file into three relational entities: item, batter, and topping. These will be written to a comma-separated file. You start with creating the hierarchy structure, then creating and running the mapping. Click Next to start the exercise. Click New to create a new hierarchy schema. Select Components. Select Hierarchical Schema. Click Create. Click on the Name field to name the schema. Click on the Upload button to select the schema or sample file. Click Choose File to find the bakery.json file. Select bakery.json. You can inspect the data in the file and check whether it can be used. Click Validate to check. Click OK. Click Save to save the hierarchy schema. Now the hierarchy schema is created, it is time to use it in a mapping. Click New to create the mapping. Click on the source to configure the source file. Click the Source tab in the Properties pane. Select the source connection by clicking the down arrow next to the connection field. The source file resides on the local file system. Click the connection C2C_FF_input. Click Select to select the file to use. As explained in the presentation, using the file input method and a source file containing the file name to process is better. This source file looks like this, with a header line on the second line the file name. src file.txt is already highlighted. Click OK to select it. Click on the little blue ellipsis between the source and target to add a transformation. Select the hierarchy parser. Click the Input Settings tab in the Properties pane. Here you choose between buffer and file input. Select File. Next, select the hierarchy schema to use. Click Select next to the schema field. Select the hierarchy schema AHS_bakery you created earlier. Click Save. Connect the source to the hierarchy parser. Click in the outgoing arrow on the source to connect it to the parser. Click on the Input Field Selection tab. On this tab, you'll link the input field to the hierarchical schema input field. Click on the input field path to link it. Next, go to the Field Mapping tab. The field mapping work best with the Properties pane maximized. Click the Maximize button on the top right of the pane. Click on the plus button at the top of the schema structure to expand the schema. The structure, as defined in the hierarchy schema, appears. Check the box next to the root array entry to select all fields. Click Map All Descendants to select all fields in the structure to be mapped to the output. Three output groups are created in the Relational Fields part on the right-hand side with all the fields copied. Click on the Output Fields tab on the left to check the output. The three relational output groups show here, and you can modify the names, types, and precisions. No need to do this here. Click on the Restore icon on the top right to return to the non-maximized view. The next step is to link the output from the hierarchy parser to the target. Click on the outgoing arrow to link it. A pop-up appears, asking you which output group to use. Click the root output group to use it. Click OK. The root output group is now linked to the target. Click on the target to configure it. Click on the name field to rename the target to target_root. Click on the Target tab to specify the target connection. Select the target connection by clicking the down arrow. Use connection C2C_FF_output. Click the Select button next to the file name field to specify the output file name. Click the Radio button to create a new file at runtime. Click on the name field to name the file item.csv. Click OK to complete the output file configuration. The first target is complete. You will have to add two more targets for the batter and topping output groups. Click on the target in the toolbar to start this process. The mapping is complete, with two more targets for batter and topping. Click Save to save the mapping. Now, let's run the mapping. Click Run. You see, the runtime environment is set to the local cloud secure agent. This is correct. Click Run to run the mapping. The mapping run has been completed successfully. Click on Explorer in the Windows toolbar to check the output. The mapping has created the three output files for item, batter, and topping. Click on the file item.csv to open it. The file item.csv opens, and you see the three types of donuts. Note that the hierarchy parser has added an extra column called pk_root, which the other two files use to refer to the item. Here is the file batter.csv. Here you see fk_root, referring to the items file. And finally, this is the toppings file, again with the fk_root column. This concludes the exercise. Click Next to return to the presentation. In this exercise, you will use the hierarchy builder to construct a JSON file from three flat files. The flat files contain items, batters, and toppings. They are copies of the files you created in the hierarchy parser lab. The mapping already has the three inputs configured, so let's begin by adding the hierarchy builder. Click the hierarchy builder in the transformation toolbar to drag it into the mapping canvas. The first step is to assign the hierarchical schema. Click on the Output Settings tab in the Properties pane to do this. Click Select to select the schema. The schema to use is called HS_bakery_0502. It uses a file with only one JSON item, as discussed in the presentation. Click on the hierarchical schema to use it. Click Save to use this schema. Next is connecting the three inputs to the hierarchy builder. Click the outgoing arrow as source_item to connect it. Click the Incoming Fields tab. A warning message shows, saying there are field name conflicts. This is caused by all three files having the field's ID and type. Click on the blue message Resolve Field Name Conflicts to fix it. This window lets you resolve the naming conflict by bulk renaming per source input. Click the down arrow next to the options for source_batter to select the renaming option. Select Prefix from the pull-down menu. Click on the Specify column for source_batter to set the prefix. All three inputs have been renamed with a prefix. Click OK to save the conflict resolution. Click on the Field Mapping tab to configure. The field mapping works best with the Properties pane maximized. Click the Maximize button on the top right of the pane. To map the fields, first, expand the input and output structures. Click on the Expand All icon in the hierarchy fields. Next, do the same for the relational fields. The input structure shows all the fields, but the relationship between the inputs is not defined. You can set these manually by defining primary and foreign keys. Click on the key icon for the field I_PK_root. The Mark as Key pop-up window comes up. The field is by default marked as primary key, which is OK. Click OK to accept this key setting. Next, click the key icon for B_FK_root to set this as foreign key. The pop-up comes up again. Mark the field as foreign key and ensure the related group is set to source_item. Click OK to save the foreign key setting. The primary and foreign key icons are slightly different, making it easy to see the relationship. One more foreign key to define. Click on the key icon for T_FK_root to set it. The next step is mapping all fields from the input to the output structure. Do this by dragging each field to the corresponding output. Click on the I_ID field to start the process. All fields are mapped, so now the mapping can be completed. Click the Restore icon on the top right to view the mapping canvas. Connect the hierarchy builder to the target by clicking on the outgoing arrow. Save the mapping. The mapping is ready to run. Click Run to execute. Ensure the runtime environment is set to the local secure agent and click Run. The mapping run is complete, and you see 3 rows processed. That is the number of items in the input, so it looks correct. Click on the Explorer icon in the Windows toolbar to validate the output. The output file is called bakeryout.json. Click the file to open it. This is the generated JSON file. Item 1 starts on line 1, and item 2 starts on line 47. The item has the batters and toppings in 2 arrays, as configured in the hierarchy builder. There are 2 things to note when creating a JSON file using the hierarchy builder. First, there are no square brackets at the start and end of the file to indicate an array of items. Second, there are no comma separators between the items. You can add these using post-processing transformations, as shown after this exercise. Click Next to end the exercise and return to the presentation.
The Hierarchy Builder lab showed that the output needs some post-processing to complete the JSON file. This consists of two steps: add the comma separator between the root elements, add the array brackets at the start and end of the file. You can do this using the following transformations. Aggregate all outputs from the Hierarchy Builder, separated by a comma. Ensure the precision of the output field is large enough to hold the complete output. Add an expression at add the start and end square brackets to the output. Alternatively, you can create an operating system script to do this. Welcome to the Hierarchy Processor module. The Hierarchy Processor is only available in advanced mappings. It uses the power of an elastic cluster to process complex and large hierarchies. Unlike the hierarchy parser and builder covered in the previous section, the Hierarchy Processor doesn't need a hierarchy schema. You will define the structure within the transformation, which gives more flexibility. There are 4 processing options. Hierarchical to relational, to convert hierarchical input into one or more relational output groups. Hierarchical to hierarchical, to process hierarchical input into a hierarchical output with a different structure. Hierarchical to flattened, to convert hierarchical input to a PE or partially denormalized output. Relational to hierarchical, to build a hierarchical output from one or more relational input groups. An example use case for converting hierarchical to relational format is that web orders are received from a web application and must be stored in a relational operational system or data warehouse. The order file will be split into customer information such as ID, order information such as order number and date, and order line information such as the type and quantity of products ordered. The Hierarchy Processor will analyze the input file to find the structure and field definition. In the configuration, you define the output groups to which data needs to be moved. These output groups represent the different relational objects to write the data. Optionally, you can add field-level transformations. In the mapping, these relational objects will show as targets, either directly linked to the Hierarchy Processor or with transformations in between. You can easily convert one hierarchy structure to another using the Hierarchy Processor. It also allows for field-level transformations or aggregate functions. The input hierarchy is derived from the input file, like the hierarchy to relational method. In the Hierarchy Processor, you define the output structure by using the input fields and, if necessary, adding extra output structures, arrays, or fields. In this example, which you will build in one of the exercises, you see 2 count functions added at the bottom of the output definition. These count the number of batter and topping entries in the input file, grouped by the item_ID. The grouping is specified on the top-level output. The flattened output option lets you denormalize a hierarchical file into a flat structure. Every child element of the structure will result in a separate record in the output, with all the parent fields repeated in every record. The flattened output does not support transformations. All selected field will be copied as is. When a transformation is needed, add the necessary functionality in the mapping downstream of the Hierarchy Processor. Configuration of the flattened output is the easiest of the 4 options. Define the mapping source as the hierarchical input, configure the Hierarchy Processor as flattened output, and select the data you want to denormalize. Connect the Hierarchy Processor to the target and select the target format as flat. If needed, add transformations between the Hierarchy Processor and the target for any post-processing of the flattened data. The final option is relational to hierarchical. The data used to create the hierarchical file is often stored in multiple relational tables or flat files. The hierarchy processor lets you join multiple inputs to create the output structure. In the configuration, you define the input streams and how they must be joined. Adding filters lets you select specific records only. You can add field-level transformations to modify the output. You can add additional output fields if needed. Add the output field and configure an expression to convert input data or do calculations. The hierarchy processor creates a hierarchical structure according to the configuration. Ensure that in your mapping, you have specified a hierarchical output format in the target. Time for some exercises. In
this exercise, you will use a hierarchy processor transformation to parse a hierarchical file and convert it to 3 relational outputs. Click New to create the mapping. The hierarchy parser is only available in advanced mappings, running on an elastic cluster. Click the Switch to Advanced button to create an advanced mapping. A pop-up appears explaining the features of advanced mappings. Confirm the switch by clicking the Switch button. Give the mapping a meaningful name by clicking the Name field. Click the source in the mapping canvas to configure the source file. Click the Source tab in the Properties pane. Click the Connection field to select the source connection. The source file is located in the AWS S3 file system, and you will run the mapping in the serverless environment created in the Runtime Environments module. Select the connection S3_IPSDE_serverless to connect. Click Select next to the Object field to find the source file. Select the file bakery.json. Click OK to use this file. The Format option appears under the File Name field. Click on the field to view the format options. These are the options. Choose JSON. Now, let's add the hierarchy processor. Click on the little icon between the source and target. Select the hierarchy processor. Configuring the properties works better with the screen maximized. Click on the Maximize button on the right. Click the Incoming Fields tab. The incoming fields are auto-populated by scanning the input file. Unlike the hierarchy parser, the hierarchy processor doesn't need a schema. Click the Hierarchy Processor tab to start configuring. Click the Expand All button to expand the input. Click the Add option next to the input to add the structure to the output. The hierarchy processor will create a new output group because there are none yet. Click the New Output Group Name field to name the output. Click Add to add the output. Next, go to the batter array and click the Add option. As for the items, create a new output group. Click on the Name field to name it. Click Add. Similarly, the output group for toppings has been added. To link the batters and toppings to the items, it needs the ID field of the item. Click on the Add option next to the ID field in the input. Click the pull-down arrow next to the output group field to link the field to an existing group. Choose the batter output group. Click Add to add the field to the group. The field is called ID1. Click on the field name to rename it to something more meaningful. The same steps must be done for the topping array. Click on the Add option next to the ID field in the input to start it. The field is added and renamed as you did for the batter, so the configuration is complete now. Click the Restore button on the top right to return to the mapping canvas. Expand the output groups of the hierarchy processor by clicking on the little plus sign at the bottom of it. Here you see the three output groups of the hierarchy processor. Link the item group to the target by clicking on its outgoing arrow. Click on the target to configure the output file for item. Click the name to rename the target. The target now has a meaningful name. Click the Target tab to configure the connection and file name. Click the Connection field to select the connection to use. Select the connection S3_IPSDE_serverless. Click Select to set the file name. The file does not yet exist, so click Create New at runtime. Click the Object Name field to set the file name and path. Click OK. The final step is setting the output format. Click the Format field to do this. Select Flat. Similarly, the other two output groups are written to output files, as seen in the completed mapping. Click Save to save the mapping. Click Run to run the mapping. Ensure the runtime environment is set to an advanced cluster and click Run. The run has started, and you can monitor it by clicking on My Jobs in the pop-up window. When the run completes, go to the S3 file system and look for the output. The three output files are located in the highlighted directories. The files look like this, with the primary and foreign keys all correct. This concludes this exercise. Click Next to return to the presentation.
Following two labs, you will use the hierarchy processor to parse.
In this exercise, you will use the same bakery.json file as input. The output will be another JSON file, containing the counts of batter and topping per item. The source is already configured, similar to what you did in the previous exercise. Click the hierarchy processor transformation in the toolbar to start the configuration. Click the Hierarchy Processor tab in the Properties pane. Select Hierarchical Output. Expand the hierarchy processor inputs by clicking the plus sign on the top left of it. Click on the outgoing arrow of the source to connect it to the input of the hierarchy processor. You need the batters and toppings in separate input groups for aggregate functions. Click on the outgoing arrow of the source again to link it to a new input group. Repeat the step to add a third input group. Now you can configure the hierarchy processor. Click the Maximize button on the right to maximize the Properties pane. You see the three input groups on the left. Click the Expand All icon to expand them. Click the Add option next to the ID field to add it to the output. Click the ellipsis to assign the ID field to an output group. Click the output group. Click OK to add the field. Click Add. Repeat the same steps for the other three fields: type, name, and PPU. Click Add next to type to do this. The four fields are added to the output. Click the little down arrow next to the input group to collapse the structure. The next step is the Add the batter array to the output. Click Add to do this. Click the ellipsis to assign the batter array to the output. Select the output group called Output. Click OK. Click Add. The same steps have been executed for the toppings array. The next step is specifying how the three inputs must be joined. Click on the Data Source button next to the output group. Remove the existing data source to start clean. Click the plus sign to add the data sources. Click the down arrow next to the source field to select the first source. Choose Input as the first source. Click OK. Click the plus sign to add a second source. The second and third sources have been added, similar to the first. The next step is to configure how to join these sources. Click on the Join button. Click the plus sign to add a join condition. Click the left data source field. Select the input group as left data source. Click the Join Type field. Select the inner join. Click the right data source field. Select Input 1. Next is to configure the join condition. Click the Condition field to start. The join condition for batter is added. Now, let's do the same for topping. Click on the plus sign to add the condition. The join conditions are complete. Click Save to continue. To do the counts, first you must define the group field. Click on the Group by icon in the output group. Click the plus sign to add the Group by field. Click the Group by field. Click the ID field in the input group input. Click OK. Click Save to complete the group by configuration. The number of batters in the batter array will be stored in a new field. Click the plus sign in the output group to add the field. Click the name field to rename the field to batter_count. Click the field type to change it to integer. Click Advanced Options. Mark the checkbox to use this field to aggregate values. Click the Output field to select the array to aggregate. Select Batter and click OK. Click Configure to define the aggregate function. Click the down arrow next to Output fields to switch to the available functions. Click Built-in Functions. Expand the aggregate functions. Here you see the list of aggregate functions available. Click Count to use it. Switch back to the fields by clicking the down arrow next to Built-in Functions. Click Output Fields. Now, add the required field to replace the highlighted expression in the count function. Expand the batter array to find the batter ID. Add the ID field from batter. Click OK to save the aggregate function. Similarly, the count for toppings is added to the output. Click Restore on the top right to return to the mapping canvas. Click on the plus sign at the bottom right of the hierarchy processor to expand the output and link it to the target. Click the target object in the mapping canvas to configure. The target is configured to write to S3, and the format is set to JSON. Click the Incoming Fields tab to configure the fields you want to write to the output. The default is to write all fields to the target. For this output file, you only want to write the item fields and the counts. Click on all fields in the Field Selection Criteria column. Select Named Fields. Click Configure to select the fields you want to add. Click the ID field to add it to the output. All the required fields are selected. Click OK to save. Click Save to save the mapping. Run the mapping. After a little while, the job succeeds. For each item, a separate file is written to the S3 file system. Here are the 3 output files. You see 6 output fields, the 4 item fields, and the 2 counts. This concludes the exercise. Click Next to return to the presentation.
Hierarchical file to create a relational and a hierarchical output. Click on the buttons to start the exercise. After you have completed the labs, please move forward to the next section. Cloud Data Integration, Hierarchy Processing Course Summary. In this course the following topics were covered. A brief overview of hierarchical files. Using the hierarchy parser to parse hierarchical files. Using the hierarchy builder to create a JSON file from relational input. And, using the hierarchy processor in advanced mappings to read and write hierarchical files. Now, it's time for some review questions. Topics covered by the Cloud Data Integration series include Concepts and Architecture, Predefined Tasks and Mass Ingestion, Runtime Environments, Mapping Design and Development, Parameters and Dynamic Mappings, and Hierarchy Processing. There will be a comprehensive assessment at the end of the 6 courses. You must score 80% to pass the Cloud Data Integration series. Thank you for completing the Cloud Data Integration, Hierarchy Processing course. Please click the Exit button to complete this training.